Okay. So there were many built-in functions, some modules which are present in Python. The moment you install, you will get it. One such module is collections. Collections module will have a lot of collections related activities. Though the name is like synonymous to your collections, means list, tuple, set, and dictionary are also collections. Then what is this collections doing means it will have some standard predefined solutions for the some problems that you face in real world. Means if you see the DAR, you can see that chain map, counter, order dict, and all these things. I told you order dict is something which used to be there earlier when we don't have a dictionaries are unordered at the time that used to do. Nowadays it was not there, but still a lot of functionalities are there if you see. So let's see some of them and how these things will work. So if you want to know any module, how to work with it, after importing, you can do a help. Help is a built-in function. If you apply, you will get the entire help documentation. It will contain the documentation about this, like what is the purpose of this module. It is saying that container data types, like for everything, I will help you. So mainly with name, tuple, DQ, chain, order dict, and default dict, it is same. And if you want to know more about this, they gave a link also for the 3.11 version. So you have in a library. You can get help locally also in that link also. How they created, we will, when we are doing our own module, I will tell you that. Among them, the most common thing is collections.counter. What is the purpose of this collections.counter? Say till now, I will tell you what is the actual purpose of it. Then slowly you will understand. If I have some values and I want to know how many times these values came, what is the purpose? How do you solve this problem? If you are given some numbers and you are told to tell how many times A is present, how many times B is present, how many times C is present, how do you tell that? So typically you need to create a dictionary to do the same. Means, so we need to take one value at a time and do the processing. So don't you think that I did the same? Means I take the counts as like some variable, which is like a dictionary. Each time when I'm processing, I need to check like for each in, for each in this list. So given list, right? Some given list. I am marking it as a list. And each time I go and I will check like whether it is already present or not. If it is not present, then I will create. So don't you think we did a similar problem solved earlier, right? So if I do of each, so plus equal to 1. So if I try to do, as it is already not there, it throws an error. To avoid that, what you will do? This would be equal to, so initially for the first time, you do like counts dot get of each character, right? And when you don't have a value, you replace with a 0. So that is how you do. So I exactly did the same thing. So you create a dictionary, you loop over it. Each time you take the character and try to get its count. So if it is not there, existing count is 0, then I can it. Slowly if I add, I will get some values, right? Instead of you writing this much logic and doing it, you can do that in a one shot using collections.counter. If you do collections.counter, same thing will happen. Did you see now? In collections.counter also, it is creating a dictionary only. So, but it's of a counter type, but you can use like a dictionary. So it is also getting all the keys and the values. And the beauty you see, the results are coming like, so in terms of order you have given as it is. And similarly, if you are given a string now, for the string also, if you want to calculate the total number of occurrences of each character, so don't you see that I wrote the logic like this to do it? So instead of we doing like that, we can do collections.counter. If I do, here also the same thing happens. For each character, how many times it's coming, it's getting. So similarly, for a collections.counter, you can give any iterables. So even a dictionary is also iterable. If you pass a dictionary, anyhow dictionary is there like, right? So it will give dictionary as it is. But if you pass like a key equal to value like that, then also it will create a dictionary out of it. Similarly, if I pass like a tuple of tuples, did you see here in this case? If I pass a tuple of tuples, so it will tell like this tuple wise, exactly this inner value is a tuple, right? Is the same tuple coming again? So is the same tuple coming again? Like that it will check. So if I say collections.counter, did you notice that this tuple as it is didn't come again? So Yashob yellow is there, Yashob red is there, but shame Yashob yellow is not there, right? Again, that's the reason each time it is showing a key and a value. The key is the individual tuples and the value is the one. So like that, in a dictionary we can take anything is a immutable object only, right? So you can do that. But what if I define inner values like a list? Then it will throw an error, right? Because for a dictionary key, we cannot have a mutable object. Similarly, so if I have these colors, I know that in these colors, there are two things, the name and the color, right? For each time. So when I'm looping, so don't you see, for the same list tuple of tuples, I am doing a comprehension and each time I get a name and color, but I use only name. If I use only name, then I'll get only names. So from this tuple of tuples, I want only names. So don't you see that I did like this? And now this result, if I pass, means only names I am passing right now. Or similarly, only colors I am passing. So each name, how many times it occurred, or each color, how many times it occurred. So like that, counter will anytime get the frequency. And also not only getting the frequency, it will give the values in the order of their occurrence, counts. See, yellow occurred most amount of times, right? That's why yellow came first. Next blue, next green means, so first by the frequency, and within that frequency based upon the alphabetical order. You see RBG, blue, green and red, all three got the same one, right? But B comes first in alphabetical order, then G, then R, then S. That's the reason they came like this. So counter will give that kind of frequency. Similarly, not only that, you can create an empty counter and you can subsequently add the values. See, initially the counter is empty, right? Then like I updated some values. Then it will try to check each of its occurrences and gives the result. And subsequently, so I am trying to say A equal to 1 and B equal to 5. I am asking an update, not add, right? Update means for A, it will check. Hey, A, do you have value? Yes, A for 3 I have. So now you see, what is the value of A? It became 4. Means when I do update every time, so here it is saying it is trying to add. If you have an ordinary dictionary and do a dot update, the latest value will overwrite. So here, so not overwrite, but so values will increment. Values will increment. So that's why for A, so it is like existing value 3 plus 1, 4. Hope you understood now. That is the difference between an ordinary dictionary and a counter. Similarly, so earlier I took a empty counter and added all these things, updated. Similarly, this time I'm taking a counter and of these values directly. So means when I looping, I'm asking these frequencies. Or similarly, so I took some counter. For that, like I am adding one more value. If you, for a dictionary, if you want to add a key value, this is how you do, right? So like that you can do. But dictionary update and collections.counter update are slightly different. But same like a dictionary, you can get only keys, only values, only items. Like this you can get. Similarly, there is one more thing called as dot items. If I say items means again the same keys only. You get it. Similarly, update is there. Already you have some values. Then you are updating these values. Then you will get the latest changes after all. So if I say now, you can notice it. Now, what is the difference between keys and elements means? Key means like one key will occur only one time, right? So if something is, so how this will show actually like a counter it will show, right? So each key, how many times it is occurring, each key, how many times it is occurring. So that is how keys means. If you ask keys also same. Whereas elements means, so it will give the total number of values. Means E occurred 3 times, right? So instead of saying like E colon 3, so it will show E 3 times. And then X. Then like, so means in terms of their order, how they are occurring, in that order, like it will show. So so how this ordering will be for elements means depending upon the order in which they were created. Similarly, so the same thing I told you, right? Character frequency analysis. So this is one interesting thing. How to read a file. Next, in the next thing, I will show you much more clearly. But still, if you want to read a file, this is how you do, right? You do open off, give a file format. So the entire file it will read, and it will read the data. And each time you're trying to update it. Means if you go to this directory, you can find the file name will be there and you can do it. So after updating, if you ask for a big file, you are asking, what is saying? Hey, so no such file or directory. I don't have such file, it is saying. So if I go, there is no such file. Now, if I go, so how do I create? I can also create, let's say, if I go to Python, so import sys. So what do I say? Sys dot prefix. If I say, so it is saying like Python is stored in this directory. So C:/Python. Means instead of going all the way here, I can just check here. So this is also a place where Python was stored. So instead of giving the entire path, I can give this path. I don't want 2 slashes because I placed a R before, right? So if I exit. Okay. Now if I execute it, the same, you can notice it read the entire file in the license file. And from the entire license, when it read, it has this much content. If you want to see how this file is there and all this information, you can just open it here. So if I say open, and if I give that file path, it will try to open. So this is the entire, file, license file. The moment you install Python, you will get this big agreement. So you want to process the entire agreement and you check how many times each character occurred. It will give a list of all the characters and how much time it occurs. So, but like you will get a questions like, hey, give me the most occurred characters. Means most common 5 means, if I say 5 means most common 5 in terms of their order of occurrences in a decrementing order. Which is the most occurred among them? So white space. Then followed by E, then T, then I, then O, like that. So like that, if you do most common for any counter, the end result, if you do most common, if you give any number, those many times, it will give the values in the decrementing order of their frequency of occurrences. Similarly, this counter is so smart enough that like if you take 2 counters and you can get the values of these 2 counters, as you know, then we can add these 2 counters also. Generally dictionaries we cannot add. Do you remember? We cannot do a plus operation on dictionaries. Whereas here you can do. Here you can do subtraction also. Means pulling some of the values from the another also you can do. And also intersection, things which are common between both. Means the keys which are common between both. So it has some keys and it has some keys values, right? If you see here A is equal to 2, here also A equal to 2. Whereas if you see here B equal to 3 and here B equal to 1. So which is common here? In both the places B is common, but B for 1 is common in here and here. Here B for 3 are there, here B for 1 is there. So which is common? B for 1, right? So like that. So if the key and the value are both exactly same, then also it will show in intersection. And if the key and the value are not equal in both the pairs, then what is the minimum among them? That it will show. That's the reason B equal to 1 came. Similarly, not only that, it's a new operator called as union operator. So if I do total number of values, means first one plus second one, like that. Not only this counter, there is one more most important point is about default dict. So if you are aware of something called as factory design pattern, this is what is about. What is this factory design? How it is helping? Say the previous example I'm taking again. Say I have something like this, a tuple of tuples. And if I try to use pprint, hope you remember there is something called as pprint and there is another thing called as pp. So if I do pp, then you will get in the same order. As it is like a tuple, you're not seeing any difference. So whether you use pprint or pp. So if you do like the other way, it works. Now I need to parse around this one each time and try to get the keys and the values. This is very interesting, I will tell you. Till now what happens, if you want to get the frequency of something, this is how you did it, right? So if I let me open that and show you here. Okay, say the previous example I'm doing. I want to get each of the things and I want to get the favorite color of each name, means name wise. So till now what happens, each one how many times it is occurring we saw, but this time we want to check each time how much each one has. Means like I want something like this. I want to create a dictionary which contains Yeshub as a key and the value is like number of colors he has. Yeshub have yellow and also the same Yeshub has red, right? So I need to get the red also. Okay, this is my agenda. Okay, I want to create something like this. Similarly, if I have like Ali, so what is the Ali doing? Ali has only blue, so you can do like blue like that. Similarly, like Arham, so Arham has what? So only green, right?
Ali has black as well.
Yeah, black also. Then he should get like black also. Okay, so like this I want to get. Previously what we got, each time how many times it is occurring, that is only, right? But I want something like this. If I want something like this, then in that case how do I solve this problem? Means if for each person, like, so you want to get the colors. Say I created a dictionary called as favorite color, and each time I loop over this list of tuple of tuples. So each time it has two things, right? So name and also color are there. So if I say like just each in say like colors, if I say each in colors and if I try to print each, what will I get? I get like each time all the colors, right? I get like each time all the colors. But like I'm not interested in the colors, but I am interested in both individually. So instead of each, I can give two things. One is the name, second one is color. So two things I'm getting this time. So I want to work on it. So how I want to do? So favorite color of each of the name. So you know how it works, right? Initially it don't have a value. In that case, what we do? Favorite color dot get, right? We should do get of. So you get the name. So what are the name you get? And plus the new name, new color you want to add. So this is what you want to do. So but like if I try to do, it will throw an error. So if you see the reason why it is throwing error, so you will understand. 1 second. Yeah. If you see that it is throwing error because by default get will give the result. If it is not there, it will give none. So if you want default, in this case we should get a list because you are adding a list of values, right? So if I do right now, it works perfect. And after doing these things, if I ask, hey, print what is the favorite colors? So did you see you got as you need? Is it clear? So this is what you are expecting, right? You got the same answer as you expected? Fine. So now the same thing can be done in a much better ways. So instead of doing like this, so don't you know that we can do the same things in a better way? How to do else? So if I want to do, there is something called a set default. Hope you remember. Instead of doing it in one line, I can say like like a clean code dot set default of name comma empty list, and then you can do like favorite colors of name is equal to again favorite colors of name, so plus this color. Hope you understood. So whenever you're doing the same thing twice, So we can also do in the other way, right? So like plus equal to, you can do the same thing we can do in a plus equal to, right? So that's what I want to bring to your notice. Hope it's clear. In this way also you get the same answer. Now, even better way how to solve this problem. If you want to solve this problem in a much better way, there is something called as default dict. So collections.default dict. So the point is very simple. It will create a dictionary. So keys will be every time whatever you create, but values what you want. That is what you should specify. If I want the values to be a list, I place it like this. Then you see it will create a favorite list, means it will create like this. If I say favorite colors and if I ask the answer, it says it's a default dict containing list and empty list. Means you don't have value at this moment. Then how to get the values? So when you're processing, I'll tell like, I take the same list again. So default dict. And this time I am again looping or each thing. You see, so this is what we need to do. I need to loop over each of them and I need to do like this. Means I need not bother in an earlier case. So we should ensure like the key is already present, right? In the both cases are what I told. In the very first case, when the key is not there, we need to do get, or else you do set defaults as that if it is not have a key, it will create first and use it, right? The same thing happens in the backend when you do a default dict. No matter how many keys you have, you need not any time check for the key. The moment you are trying to do any operation on a key within this, it will first create that key. Now you see here, you got the same things in this way. So, but the order is slightly different, right? So it is not giving the order in which you give. Means, so in the order that we have is like first Yashob is there. That's the reason every time Yashob is coming first, Yashob is coming first, Yashob is coming. Whereas default dict, the order is different. Obviously, who will care about the dictionary order? Because we every time parse with only the keys, right? But sometimes if you care, then be aware of this change. So default dict, so anytime when you do like this, it will get the values. And you see here, not only this, you see here, if I say favorite colors of, the same colors of the same thing we are doing, right? And observe difference. Here I created a default dict of list, right? Similarly, here I am doing default dict of set. Observe difference. When you do a set, we should add the values, right? If you want to add values, you should use add. For a list, if you want to add values, we need to say append, right? So if I do write that, you can understand. The keys will be same again. Did you see the values for a set here? Values for a set. Sir, can I take a tuple? No. Because if you take a tuple, we cannot add anything, right? Hope you remember. So if I try to take a tuple, what will happen? So you cannot add to it. If I say tuple, what will happen? For a tuple, if you want to add something, you cannot add, right? So that's what not possible. But like if you want to add something for a tuple, so plus equal to, again like a tuple. So give a try. Yes, it is working. Means it is recreating a new tuple for a tuple if you are doing. Hope it's clear. So whatever data type you are taking, you can do it. Sir, can we take a default dict of another dictionary? Of course, we can do that. It's not a big deal. So fine. Next, you see, if I take like default dict of an int, so this time I'm taking one more example where I have words like apple, ball, so and so, and I'm saying default dict of int. Means the value will be every time a integer, means default is a 0. So every time you just add the values. Now you see what will happen. So you got a default dict which is of type integer with the values. Similarly, so don't you think default dict of integer is same like doing a counter? You see both the results are same, right? If I do default dict of integer also, values will increment. If I do counter also, the same thing, right? So counter is also implemented like this. Hope you understood now. Default dict. Similarly, if I give a float, so it will give the results in a floating point values. Similarly, if I have a string, I am looping over each of these. It is same like using the collections, right? Collections.counter. both will give the same answers. So if I say, so not only this result, and in the next line if I ask like print of, so collections dot counter of the same name if I give, so both will give the same answers. Here also same answers, right? So like that. And similarly, so you can do like case sensitive, case insensitive. If you want to modify the things like case sensitive or insensitive, all those things you can do. Whereas in ordinary collections, whatever comes, it will give as it is, right? So if you want to do lowercase or uppercase, so then like you need to convert everything to lower and do it. Say lower, right? You can do lower and do it. So did you see? Both give the same answers. So like that, we can use collections dot counter, collections dot default date. And the next one is collections dot dequeue. This is another big interesting thing. Till now, just imagine like a train. So you have a list, right? If you want to add the values at the end, so how you have done? If you have a typical list of values, so how do you add at the end? There are two ways. In the end, if you want to add, either we can do append or like extend, right? And you know, append means adding to the same values. Whatever you give, it will add. Whereas extend will add at the end only, but in the same dimension it will add, but it expects a mutable object, sorry, iterable object. So whereas if you want to add at any other point, so in any direction, so you can use something called as insert. So we can add. But can you add at the left side direction? So in this direction, can you add? So can you add in the starting? No. So only insert is the way you can add. So you have append. Similarly, if you want to append in the left side, append is by default right side, right? If you want to append in the left side, extend in the left side. For all those cases, you have this one, dequeue. Dequeue is where like you create one queue of some values. It has some values, right? Now, if I do append, generally, you know, append will add at the right side. If I do append of 4, you can see one more 4 is coming at the end. Similarly, if I say append left of 6, means the value will be appended in the left side. Did you see the 6 in the left? Similarly, if I do pop, pop will actually remove the value at the last. Last means in the last position, right? So if you see the output right now, you can see the value. The last 4 was removed. In the same fashion, if I say pop left, means from the left side, means at the 0th position, it will be removed. Earlier at 0th position, we have 6, it was removed. Similarly, if I say the count of 3 in Q, if I say count of something, same like a list of operations, we can do everything. But apart from that, we can also do left side additions, left side removals also. And you know, you have remove. Remove means it will remove the first occurrence, means. So that's how it works. The same old operations, how we work on a typical list, everything will work. And similarly, if we do extend of means, extend, you know, it expects only iterable objects, but it will try to add at the same dimension in the last right side direction. Similarly, if you want to add extend in the left side direction, did you see? And what are the values you passed? Those were added in a reverse direction. The first value we added is going the first and is like this direction. And not only this append and extend, append and append next, there is one more thing called as rotate. If you want to rotate the values, rotating means like, you know, so the values are there, right? So it will come like, so shifted by left and right directions. Means if I shift this highlighted part to the left direction, what happens? That 9 will go to the end first, then 8 will go to the end, then 7 will go to the end. So did you see? Those 3 were gone in the right. So similarly, you can do the reverse operations, and after reverse, you can see the same values in a reverse direction, not ascending or descender. Reverse means reversing the existing positions. Similarly, you can ask for the index, so the first occurrence of anything, second occurrence, or in the presence of in somewhere. And similarly, you can insert at a particular position. You know insert, right? In a list, how it is. If you specify position, in that position it will insert. Means at 4th position it is inserting this thing. Means existing value will not remove, it will go by one position to the right. And if I see now, you can see that the 3 is there as it is. So this is all about NQ, DQ. And next one we have is about name tuple. This is the most important thing. Till now we have tuples, right? So a tuple means if you have 3 values, 4 values, any number of values, you index by the position. If you have 3 values, you say 0th position, first value, second position, right? So if I say like 3 values are there, so Jane is there, so 29 is there, female is there. If I want to get the by position, what is the 0th value? This is how you get, right? This is like position, 0th position, first position, and second position. If I say, hey, Jane, means you get the entire tuple. If I say index, I get the value in that position. Means at 0th position, Jane is there, you got it. So similarly, by position, if you want to get each of them, you can get them. So if you have 2 tuples, you can loop them and together you can get at a time. Okay. So then what is the purpose of name tuple? Just imagine real time. Mostly when you go with as you are data engineers, I'm telling more clearly. So let's say you have a select query or insert query. So insert into some table. Say we have table columns are there, column 1, so column 2, column 3 are there, okay? And you want to insert values, and you have like 3 values. Say some value, v1, v2, v3 are there. Okay, these are like 3. What if you have like 10 columns? In real world, how many columns you'll have? Tables will have like 18, 19, 30. 30 columns also will be there. And just imagine like if you have like 30 values, and if you want to modify one among them, you will be really confused, right? Which one is belonging to whom, right? That's the biggest problem. That's why you want to work with the dictionaries, because like for a dictionary it is easy, right? If I say column 1 is some value, so column 1 is 34, and if I say like column 18 or like column 13 is equal to some value, that is easy for me to understand. But going for dictionaries is like too costly, because they store a lot of memory. For you to simply understand, so the difference I can clearly give you to understand. If you want to get the size of any object, you use sys module, right? If I say sys dot get, so size of, and if I say like empty tuple, if I say empty tuple, it will occupy this much space. If I say like empty dictionary, did you see how much space it took? So similarly, if I say like from collections, so there are 2 ways of importing collections. Directly the full module, import collections you can do, and collections.name tuple, or like directly also you can do. So name tuple is also one kind of tuple only. With just for every position there will be name, that's it. But did you see the space amount of time it occupied? Dictionary occupying 64 bytes for just empty. For tuple it means this much. Just imagine when the data is big enough, how much size variation happens. So that's the reason most of the people, when you're working like things like SQL queries where we have large amount of tuple sizes, they want for every tuple position, they want some number, a name also. You see, in this tuple, there are 3 things I showed. So this is how you create a name tuple. What are the tuple you create? Just you should specify that. You see here also I'm specifying the same thing. I created a name tuple. Okay. So if I say like sys dot get size of person, person is in fact like a structure. Okay. So it is occupying more, you see, comparatively, because the initial structure it will take. But the moment when you add values, it will be different. So for the same dictionaries, if you add all the values, you will notice the difference. You can just do and check that. So similarly, what is the purpose of this means? In the earlier things, we have like 2 things. One, we have name, age, and the gender. Similarly, name, age, gender. So for that name, age, gender, I place 3 things. Now you see, whenever I'm creating, I can pass like that. So whenever I'm accessing also, I can access in the same way. See, whenever I'm creating, it is creating a name tuple like that. And if you ask the type, it says it's of type person, means it won't tell that I'm a name tuple. So now you can access directly with the position and also with the dot name also. Means what are the label you have. Similarly, of second position you can ask, or else gender also you can ask. So like that you can work. But if you ask for something else which is not there, means like 4 values if you pass, then it will throw an error because it don't have that right class. There are only 3 fields. So this is how you work with these things, name tuples. And the next thing that you want to further focus on is after name tuples. These are some examples just for you to walk through. Yeah, if you have a name tuple, from that if you want to create a dictionary, you can say dot as dict. It will create a dictionary. And similarly, if you want to do a iterable to name tuple, means you have a name tuple ready. For that, if you want to pass new values, so you can do a make. For each time you do a make, so from that name tuple, it will create a new name tuple. And similarly, if you have 3 values, it will go and take all 3 values. Means it will iterate and take. So like different ways of doing. And similarly, fields means the keys, means the position, names, the labels that are you have. And if you want to replace something, you can use it for that. So though it is a tuple, name tuple is a tuple only, right? But you can do all these changes. How it is possible? They created their own data structure to do all these things. In fact, we also can do our own data structures once you go to classes. Similarly, there is something called as order dict, which used to be useful earlier. Now it is no more useful because Python dictionary is retaining the order in which we give from Python 3.6. So now it is of no use. So earlier, the order in which you gave and the order you are getting an output may not be the same. So to retain that order, we used to go with that. So nowadays, in real time, if you want to work with environment variables, so I can say like Python space. So this example, if I do, in OS module, there is something called as environ. If I do environ, it will give all the environment variables which are related. So maybe it is a bit messy for you to understand. It is like a dictionaries only. So if I say like, each, so environment, so name in os.environ, if I ask and print each environ, it's easy for you to understand instead of printing the entire thing. So if I clear the screen and ask, did you see all the environment variables? You got it. So what are the environment variables? Every operating system has these environment variables. These are like constants, like my computer name. Whenever I create this operating system, so I first, after installing, I give a name to it, right? So what are my paths are there? So what is my processor architecture? All these informations are there. So it is same like a dictionary. The moment you loop over a dictionary, you get only keys, right? If I do like dot values also, I get, but I will not do because there are some confidential information. You can just do like a dot values or dot key values, dot items, everything you can get. And if I want to explicitly some particular config environment variable name, how do I get? OS dot environ of, as it is a dictionary, from a dictionary I can get like this, right? So if I ask for the environment, I can do like this. Hey, I want processor architecture. So similarly, I want like processor identifier, all these things. I can get them. If I say like I want these 4 details, all of them I can get. If I print it now, did you notice what is the processor architecture? So AMD 64. So similarly, if I have some of them, if I want to get, I can pass like a list of them, and for each of them I can ask the values, right? So that is also a way of doing it. So it means like just a key value, like a dictionary, we can get it. So I want them, I can get it. So similarly, what is program data I want? And similarly, what are program files? I have these values. How to get them? For each in these things. So you want to do processing. So print of each, comma, OS dot, so environ of each. If I do for each of them, I'll get the results. If I mute them, you can understand. Instead of too much noise, you can get it. Did you see? For each of them, what is the values and others? It's like a typical dictionary. So not only that, instead of doing like each dot get, you can also get like in another way. So print of OS dot get environment of, you pass anything. Say there is something called as temp. every language will have, every operating system will have this temp path. Of course, the path will be different depending upon the operating system. So sometimes there will be something called as the TEMP also. TEMP also. If I do, now you can notice what are its path is. If I execute, I get it. Fine. You got the temporary paths also. Fine. So this is all environment variables. But in a particular project, if you want the environment variables should be variable. Say like in this particular project where I am working, I want to get the values of a my own custom environment variables. So will I go to the server every time and update it? Sometimes production servers, the migrations will happen from dev to UAT and UAT to production. You cannot touch the code. All the code will go via CI/CD process. Then how do you pass these environment variables? Again, that is a big headache, right? To avoid that, so they thought like, you create a .env file. Whenever you create any file which is starting with a dot, it is like a hidden file. Whenever you create like this hidden file, it will not go directly everywhere. So what is this hidden file means? If I do like ls command in Windows, in this directory, see, there is more than one file. If I say L also, it is showing only one. Like ls command, after L, if I say A, means I want hidden files also. After, when I'm asking hidden files, apart from the directory and current directory, leave those two. So you got a .env file also, right? So this .env file I created. So they say that you use a .env file where you write everything. So what are the key and a value, key and a value, key and a value. So whatever I wrote there, export is optional, but like generally you write like in key equal to value, no spaces in middle, okay? No spaces should be there. So then whatever you wrote, you can get it. You see in this example, you have URL format where you have things like this server and again braces with port. Means these values will be replaced here. Means you will get like www.google.com:80. So like that you will get. So like that, different things you can write. So after writing, how do you use it? There is a module called as .env. .env is a module which these days many people are using. So it is not a module which is coming by default. Then we need to install it. If you want to install -U. Capital U means what? If it is not installed, then install. If it is already installed, then update. And -user means do only for the current user. But down the line, I will tell about a virtual environment. Once you go there, so you need not do -user. So it is saying like it has installed. Fine. After that, how do you use it? Any module, if you want to use it, first we need to import it, right? So if you want to import it, you can do same like this module. So with like, so I can rename it like, so traditionally. So similarly, if I say .env usage.py, if I say another file now, I can do that. So how I can do? Yeah. So import .env and we can do it. So if I say like, Python, if I say, did you see the entire path you got? So, okay. So for you to better understand, so this is the environment path. You are getting 2 slashes just to show you in a better way. Did you see what it is saying? Hey, give me the .env file which is there. Means in the current directory, it will check for any of the file which is starting with .env. So if you have any file with .env, it will say. So it should recognize it. So once it recognizes it, you can get everything that you want. So once it recognizes it, so after that, like if you want to load all the variables, you can do it. Means, so first of all, let's say I assume I am commenting these things. Okay. Now what you have? Import OS. So OS dot get env, right? So this is how you got it. If I say get env of tmp, so obviously I will get it. And if I print it also, print of, so get env also, you can notice the same thing. What is saying? Oh, in braces we need to get, sorry. You see now, you got the environment variables because it is present. Now, if I want to get the same thing for a different variable, say like, if I want to say print of os dot get env of another thing called as Redis address, I want to get. Did you see what happened? You got none. Because this is not there, you got none. But if I say that, hey, get env, so means dot env if I do, and find location. Now we see in this case, even after using, still you get the value of none only. The reason being, after loading, we should know how to use it. Means you recognize that there is a file. Then first we need to load, right? So two things. First we need to recognize, and then we need to load it. So if I do a load, so then like you can do. So you can do directly load, or you can say verbose equal to true, or like use this find. Any of these ways, three ways you can use. After loading, now you see the difference. When I asked, hey, what is a Redis address? Did you see you got localhost something? How it got? Because it has gone to this environment variable and understood what is the Redis address, and it got it. And similarly, if I ask for multilinear or something else, it tries to get in the same lines. So now, what are the files I have within that? I can access directly. Instead of just one, means I can directly. So as if like a ordinary OS environment variables, I can access everything. So before doing that, we need to load it. If I don't do this one step called as loading, finding is different, okay? Once you found it, we need to load it. If you don't load it, it can't understand anything. So if any of these ways, if I do to load it, then it will do the job. You see? And not only that, so there is one more way of doing where you can give the explicit path. So say like this, your .env file is present somewhere else, and you want to tell specifically that, hey, use it. In that case, so we can use explicitly. How to do explicitly means we should give the path. So instead of these things, means in all these three cases, what happens? If it is in the current directory .env file, then it will recognize. But if it is in some other directory, we should specify explicitly. So means like, so from Python 3.6 onwards, there is another module called as pathlib. If you say pathlib, so it means in current directory /so and so. So same like how you do in a command line, like that you can give the paths. Previous directory means two dots, like that you can give. So you can do like this explicitly also, you can do, and you can get it. We understood? So what is the purpose of these things? And so also, like if you want to set your own environment variable also, you can further set. If I say like, after having all these environment variables also, if I want to set the environment variables, if I say like, .env.set key of, if I give like this, now we see here what happened. So you need not do explicitly setting. What is saying? Hey, you don't have permissions to do this. Means it is trying to override the existing things. So as I don't have permissions on the system too much, I'm not getting. But this is also one of the important module when you work. So the next thing that I want to touch base is on the multi-processing and multi-threading. This is a very, very important things. So be careful and give some time for the next 10 minutes. You see here, we worked on different kinds of modules. The next thing that I want to touch is on multi-processing and multi-threading. First, I will tell about multi-threading. So this time I want to explain the concepts in a instead of a Jupyter notebook, I want to do directly. So let me take that. If I take in multi-threading, there are different ways of doing multi-threading. First is like using a function-based. Function-based multi-threading. What do you mean by function-based? So let's say I'm taking like a simple example.py. I'm taking one example where I want to prove. So multi-threading. First, try to understand why we need multi-threading. Then we will see like how to get it. So anytime when you have some programs which are running, how it will run? If let's say there are like statements, multiple things. If you want to achieve parallelism and concurrency. So this is for the first time I'm using this word called as parallelism and concurrency. What do you mean by parallelism and concurrency? Say simple. If you go for any swimming pool competitions or like horse riding competitions, just imagine horse riding competitions. At a time, all the things will go at one shot, right? You will fire all the horses to go at one shot. So, and each one is not dependent on another. Everyone can go on their own phase. So just imagine now the case where you want to transport a large amount of data. Then what happens? Let's say there is a single horse. If the single horse is going every time, so from source to destination, it will take more time. What if there are 10 horses? The same work can be distributed, right? As everyone is doing, the same thing can be doing much more fastly. Don't you agree? So this is the concept of parallelism and concurrency. Parallelism means everyone running independent of every other. So parallelly it should go. And concurrency means one don't have a dependency on another. So to go easily. But coming to this, how to achieve this thing, concurrency in Python means there are two things. Not only in Python, in generally every language, in a computational world, there is using multi-threading and multiprocessing are the two things. Multi-threading and multiprocessing. What do you mean by multi-threading? Means in your system, there will be multiple threads which will be executing. So every work that you do, there will be executed by a OS thread. So those threads you can use for spawning multiple threads to execute something fastly. So how to do that? So for how do you create your own things? For that, we use something called as multi-threading module. If I say, so what is this threading module it has? If I see, you can understand that. How do you work on it? I need to go to this directory where it is present. Okay, if I go to this directory, copy path, Python, you see now, so, oh, it's a module. And if I ask the dir, that's where you understand. So it is saying like this module is present in this location. So every module that you are working on, whether it is you installed or like built in, both will be in the Python directories only. So in the lib directory, the most of the install modules will be there. So the given what are you install, those will be in the scripts folder. That's it. And if I execute again, did you see the list of attributes? It has a good amount of attributes. Means we can do a lot of things. And similarly, I told help. Help is a built-in function, which is the only function which don't need any print. So do you know any statement if you execute in Python script without a print, it will not print in the output. But only help don't need any print, it will directly print. So what it is saying, threading module is similar to what you do in a Java's threading model. What are you do there in Java? Exactly we do. Just the name changes, that's it. So thread pool, so all pool executors, everything we can have here. Okay, if you want to see like abort, means after some time you want to stop, or like reset, or like you want to wait for something. So all these the actions you can do. There were like too many things, but slowly you can learn. Let me take a small function and I want to work with it. So I will comment these two. And if I take a small function, it is a typical hello world, right? If I say like hello world, and if I execute, what will happen? Just that program will execute, right? So Python space so and so. It will execute hello world. Now, how do you create a thread and how do you start executing? So if you want to, this is like traditional way, right? So method one, so traditional means like here you don't get anything much, but using a threads, you do like this. Method two. So you create a thread first. Threading.thread of whichever you want to execute function, you give it. As this function is not taking any inputs, directly pass on. Then will it execute directly? If I execute right now, you see, traditional method, I will comment it. Now if I execute, did you see it is not executing? Means creating a thread is one part and starting the thread is the second thing. If you do both of them, only then it will happen. Sir, what is the purpose of this? You saw one small example, right? Slowly, once you go for something big, then you will understand. If let's say this time I want to work on some worker threads, say like I created one worker thread. So this time I want to take some input and I want to work on it. So I want to take some input and I want to work on it. So this is like, so to say that like, how do you take the values and so and so. And I'm saying worker of name, I'm taking the name and I'm not returning anything. Within that I'm printing. So I'm doing a random dot choice of 1 to 5 and I'm sleeping for that much of time and I'm completing. So whenever someone executes this worker and say like if I say Uday and if I say like CLS and Python 2, you see what happened? You took one value, executed, right? So one time it is executing. Similarly, if I say like one more thing, so instead of Uday, like if I say Python again, means like that I am creating two things now. First, Uday was started. It is randomly sleeping for some time. It is completing. Then next time the next one was started. It is executing. Just imagine the same thing. If I am doing with like so for range of values for I in range of some 5 times. If I'm doing so, if I say like the same worker of I, if I do, what will happen? So after these two, so maybe like even if I want to comment also fine. This time I'm doing what will happen? First one will start. It will execute after for sleeping for some time. Then the second one will execute, sleep for some time. Third one will execute, sleep for some time. Fourth one will execute, sleep for some time, like that, right? Just imagine how much time it will take. Now, instead of doing like that, this is a traditional way of doing. So this is where you will understand the optimization of for I in range of 5. If I do like this, I'm creating a thread, worker thread. So for that, like I need to pass arguments, right? Earlier you took an ordinary thread. So this target don't need any arguments. It is just a function without any arguments. That's why you just executed and started. This time it will take some arguments that you have passed some argument also. Maybe like I'm saying computer underscore 1, computer underscore 2, like that I'm generating. And this is a tuple. See, that's why after one value, I placed a comma at the end. That's what is more important to understand. So this time if I execute Python space, same A2 so and so. Did you see what happened? Did you understand the difference? All 5 were started at one shot, right? So, and all 5 were completing parallelly. Did you see which one completed first? Computer 3 was completed first. So then computer 4, computer 5, computer 1, like that. Is it clear, everyone? What I'm trying to say? Yes, friends? So if I do the same thing traditionally and this thing, you make a comparison, you will only understand what is the difference. If I execute, see here, so first using traditionally, you see how much time it will take. 5 times means 5 times this function will start, execute, complete, again start, execute, complete, start, execute, complete. Whereas if you are doing the same thing using a threading, did you see all 5 are started at one shot? Of course, every program can have its own way of doing, right? It will have less time or more time. But ultimately, if it need to be completed, this is how you need to do. Hope you understood. Similarly, let me go with one more example. If you are understanding these things, what are I'm trying to say?
Yes.
Similarly, let's say this time I created one more function. This function display, within the for loop, it is executing for 10 times and I'm printing something. Okay. So now I want to start it. So thread, and I want to execute. You see now what will happen. So I created one function. So I created a thread. For that thread, I passed this target and I'm doing a start. Now you see Python A3. You see what happens each time. So 10 times it need to execute, right? So generally, if you this function is their display function, if I execute, what will happen? It should tell that each time when it is executing. So similarly, when you're printing, means like first, if I say display is a ordinary function. If I ignore all these things, you can notice that. If I ignore all these things, you can notice that. If I execute again, you see, after executing this function, 10 times it will play child thread, child thread, child thread. So, and similarly, if I do the same thing via this threading instead of directly, you see now if I execute, what will happen? This time also it started and executing the other one. And along with that, if I execute the other statements, means generally what you know, if there is one statement in the first line, after that completed only next one will start, right? After that completed only it will go to the next lines, right? Whereas this time you see, you created this thread, you started it, then you go on to the next lines. So additionally, what should happen? First, this display function should completely complete, then it should go to the next one. But you see, what are you executing? It is executing in this way. So maybe like for child threads, I will add a /t for you to better understand, recognize. If I say Python A3, Python, okay, you see what happens? So when your child thread means like threading is executing, at the same time, it will not wait for entire things to complete and then execute the next lines. Even my work is also executing, right? The next lines also, without waiting for the previous one, it is executing. That is what I want to prove. So in the same fashion, if you are executing on any thread and if you want to get the thread information, so you can get the thread information also, like about the threads, like what are you executing, what all things you want to get. So I want to make it quick because it's very simple to understand. If you are executing any thread, so if the thread is not taking any arguments, what you do? You just don't pass any arguments, right? If your thread is expecting any arguments, you need to pass like a tuple. I showed you previously also, if you have single argument, you need to pass a comma at the end, I told. And similarly, for a thread also, you can give some custom names also. When threads were executing, instead of just execute, you can give names also. And if you create the threads, it will not execute. You need to follow them with a start. If you do a start only, you will get it. So till then, you won't get all those things. You see, you created a start also, you got it. Now, within the thread, I can ask certain information. So threading is a module which we are using. And within that, you can ask what is the current thread. So you can get the current thread, and current thread context you can ask. What is the thread dot name, thread dot underscore name. So next, like indent. So I wrote the complete definition of what is it for. And thread ID means operating system will give the thread ID for us. So is the thread still alive? Is it stopped? What are the arguments, keyword arguments of the thread? Means inside the thread, if you want to access all of them, you can use it. What is the daemon means the background job which is running for this to execute. If I say Python, so B1, you get all the information regarding the threads. First, you for your traditional way, so using the second one. So like that, every time if you want to get the thread information or anything like that, you can rely on it. So not only that, let me go for the next big thing. If I say like, yeah, if I have multiple threads, like then how do you join those threads? That's the most important point. So let me do. Till now we have like two threads. We are just starting, right? We have two threads. We are starting. Then what if you have like 10 threads, 20 threads? So how do you work on them? So let me give one example where you can understand. So this is how you are printing some prime numbers. The logic is not mandatory here. You just walk through it afterwards, you'll understand. But the point I want to prove here is that if I have like threads, you see the get prime number. So, and it is taking this thread. Okay, hope you can understand. Can you acknowledge?
Yes.
Yes, fine. So get prime numbers are there. This thread you are creating and you are starting. And there is one more thing called a join. Till now, you never used this thing called as joining. So now we see what will happen. So B3, earlier also we have threads. Now also we have threads. So this join threads waits for the prime threads to complete. Earlier you remember, you see now, if I comment this line, what will happen? I told you previously, if you have some thread created and after that you do some actions, it will go on executing everything. You see, I commented this join, right? When I commented this join, did you see it is executing everything? And okay, so this prime number is fast enough to execute. That's why it gone to the next line. So what is the point of this join is that, so till this line is done, it will wait. Then it will execute the remaining things. Let me give you one more examples where you can better understand. So when you have like 2 or 3 or more, it can really help you. So let me go for one more case. If I work on threads, say like um, I have 2 tasks. So each task I am printing what? The current thread dot name and os dot get process ID. Similarly, thread name and process ID. Like that, I created 2 tasks. So now, you know what is the process ID, right? So when the process is executing, it will create one ID. Every process in the system will execute. Process means everything that executes are process only. Even the VS Code or be it the browser or whatever might be executing, it will execute with a process. And each process which is executing in the operating system will have an ID to uniquely recognize it. That is called as process ID. So what are the process it is executing? So with that, if you want to be aware, CLS and Python space B3 join threads. Okay, fine. See in this example. So this is your main thread. So what are the main process is executing? For that also it has a thread. So that main process name. You see, for the main thread means the program executing also needs one thread name. You don't have any name. So the main thread will be having the main thread name. And similarly, if I create 2 threads, whenever I create a thread, optionally I can pass a thread name also, right? I passed. So these are like a child threads. Imagine like this is like a parent thread or a main thread. So within that you have the child threads, which were spun by this main thread. Now we see what will happen. How we execute is that first create the threads, then start the threads, lastly join the threads. So wait till T1 thread is completed. The moment you did a join, till it is completed, it will wait. So till T2 means till it completes, it will wait. Means it doesn't mean that until unless 36 line is completed, it will not go to 37 line. No, not like that. It will ensure that 36 line is also completed, 37 line is also completed independently. But only after all of them were done, the next statements will execute. So if you see right now, you see now what will happen? Did you see that this end came only at the last statement? So till everything was completed, this end statement didn't come. So this join ensures that what are the threads you created will execute and separately you get it. Now, did you all understand in this program 2 things? The main thread, even for executing these threads also, it needs a main thread, right? For the main program. That thread is called as a main thread. And what are the threads you create are called as child threads or subthreads, what are the name you call. And for the subthreads, you can also give a name called as what are the name you want. So like that, you can execute. Okay, I'm going one step ahead to these threads. So if I go one step ahead for these threads, I can create like this time very small thing, just like a foo. That is just like a one thread I want to create. Now I want to execute the same thing multiple times. So if I say like, till now, if I say I have like multiple threads, how do you create? So t equal to thread. This is how I create, right? You do like t dot start. So like we need to join. So for doing that, so t dot start, if I do t dot join, I do. Okay. If this is how I do CLS and Python. So B3. If I execute, what will happen? Yeah, everything is executing. And if I have finally like, so t dot join. If I execute like this, what will happen? Everything will execute. At the end, it will have. But if you just want to execute, fine. But if you want to do multiple things, you want to make more control on these things. So then like what? We need to have these threads stored somewhere and you get the results. Means instead of creating a thread, joining and starting all at one shot, we can pass these threads to some list and store those threads there. So after that, you again do start. After that, you do again join. You may ask me, sir, like 3 times you are looping, right? Unnecessarily. It doesn't matter. In terms of code complexity also, O of n plus O of n plus O of n, result it would be O of n only. Means like overall, it is not a big burden. Overall, what if you're doing like this, you will get a lot of control. And when you're outputting also, you get the same logic. Performance will not alter at all. But if you are doing this kind of appending, you get more control on your threads when you're working. So especially when you are working on this threads appending, so one thing I want to bring to your notice is that, so for these appending threads, if I go on, say, so let me give one more example. So this time I created a hello world. It is taking some number and those much time it is sleeping. So the same thing I pass. This time I pass the same hello world and argument I'm passing. It is same like in the previous case. Every time I create a thread, I am appending. After appending itself, I am starting. See, join itself I'm doing separately because I want to wait, right? So if I do the same join here only, then what happens? So it will be like a overburden, right? So instead of checking and waiting for all to complete, so it is ordering in this way. CLS and Python, so B3. If I see here, it will execute. So from 5 to 0 with a step of -1 means, so first 5, next 4, 3, 2, 1, right? So those many numbers it will be passed. Means the first thread will wait for 5 seconds to complete. Second thread will wait for 4 seconds. So like that it will wait. So that's the reason. So the first thread, though it is started, 5 thread was started first, it is executing at the end. So thread 5, so the hello world 5 is waiting for 5 seconds. So did you see? You can give a try with changing these numbers to get understanding of these things. So not only that, if you want to know how many threads are executing, what are the active threads, so what are the passive threads, means inactive threads like that also you can get. So like I have one function. If you take some seconds, same like in the previous, it will wait for that much seconds, sleep, and then complete. So now I have one more function called as list active threads. Means with the threading module, you can get the active count. Active count means what are the threads you are created. See, in this case, you see initially I'm asking, hey, how many threads are active here? You see, in this case, what will happen? Can you tell me how many threads are there right now? You didn't create any thread on your own, right? But it will say the count as 1 because so even the main program is executing, right? Even that is also treated as a thread. So if I say, oh, hey, list the what are the main threads means it's only one thread. And after that, say, if I created one more thread. So if I created one more thread, you see, in this case, I created one more thread, but I didn't start the thread. If I execute right now, even after creating one more the thread, still the active threads are like only one because you didn't start. So only when you start the threads, things will change. If I say this time I started one thread, did you see what will happen now? The moment you started a thread, the thread counts become 2. See, apart from your main thread, the thread you created, like that also will come. Say, like if I going further, if I say this time I'm creating 5 threads, and you see now what will happen. So here itself you'll understand. What is the purpose of going for a thread? Thread will take ordinary job and make it concurrent. So how it will do? If I say like Python space, you see in this example what happened? If I do traditionally the same function, if I need to execute 5 times, it will execute this much amount of time. It will start the first one, execute, start the second one, execute. The biggest problem is not about finishing. The biggest problem is starting. It cannot start all of them at one shot, right? Only after the first function was completed, the next one will start. Whereas if you are doing a threading, all will start at one shot. Of course, each function has its own way of doing. Some function may complete in 1 second, some function may take in 10 seconds. But executing all at one shot, that is what concurrency that you are achieving. But will it execute all one shot? That is up to them. But now, did you understand the process? So this is how you work with threads. And if you want to join them, I told. How do you append them, I told. And if you want to list the active threads and all those things also, I told. Now the next point within the threads is about daemons. Daemon, if you are aware of Linux operating
I
system,
Uday, sorry.
yes, please.
Can you just complete the last one that before the ending the Zoom meeting? Because we
So
are in.
this one, the current active threads.
Yeah.
If you see the
So
current active threads
okay. Yeah.
issue here. So this program also same thing happens. So what I told, when you just create everything without anything else, just 2 functions are there, nothing is called, so nothing will happen. And if you just ask, this is a function for getting the list of the current threads. Threading.active count will give the active count of threads. And if you want to get the list of all the threads, you have threading.enumerate. If you execute this, what will happen? Python space. So if I ask get active threads, you can notice that it will give the count as only 1, because no thread was created by you. The main program was running. That is the only thread it has. Then subsequently, if you try to create one thread, but still you didn't start, even if you create a thread, if you don't start, it makes no difference. So only one thread is active right now. Means other threads are there which is inactive, right? This thread was created but is inactive. Whereas the next time you start a thread, so then like now the count will be twice. So because there are 2 threads, apart from the main thread, the one more thread that you created will be there. Similarly, if I create like this time 5 threads, so if I do 5 threads, then obviously it will execute and it will give 5 threads. And observe the difference. If I do like, so t2.join means the thread which I'm creating, if I'm joining, if I join them, it will execute concurrently. If I don't join, they will execute sequentially. So that is the only difference. So, but totally you count, you see. And the next point in the threads is about there are 2 types of threads. There is something called as a daemon. What do you mean by daemon means what? Whichever happens in the background is called as a daemon thread. So next you will learn something about, so yeah, um, you know, in import threading. If I say there are 2 types of threads called as daemon thread and non-daemon thread, maybe like I'll write the logic here. So first of all, to understand this process, I want to show at what time something happened for you to better understand. There is a module called as logging. Next, we will learn about that logging module shortly. So to understand that, I give this module. So simple logging means it's like a print only, but it will give the timestamp and all those information. Then we will go afterwards, like what is this logging, how it can help us, and all these things. If I say like some name called as logging.start, if I say logging.start, so, and if I say print of v7, you can notice that it is doing. Okay. So instead of just printing like this, it can also give like information. So if I do like just a print statement of starting, observe the difference between these two, how it is working. If I just do start, it will say start. Whereas if I do like this, it will give the thread name which is executing also. Just because of that, I am using this module. Logging, we can do a lot many things. But for now, I'm just using it for this purpose only. We understood the difference between an ordinary print statement and a log. So ordinary print just prints, whereas a log with I can tell which thread is also executing. With this, I want to create functions. So function one is like into daemon. The second one is a non-daemon. What is the difference I want to tell? So I want to use a time module because I'm doing time.sleep of 0.2 seconds. Daemon thread means one which is sleeping idly. Means simple in a real world example means daemon thread means one T which is running in the background. Those are called as daemon threads. So non-daemon threads. Just to show you one daemon thread, I'm making it to sleep for some time. Ordinary thread without sleeping. Now I'm using the threading module, import threading, and I'm using it. You see here, I created now two threads. You know, target is like the function name, whatever you have. Did you see I added one more attribute called as daemon? Daemon means like run the process in the background. That's what it means like. So, and you know, once you created the threads, the next two part is what? To start them and then to join them. So these were the three steps we have. Till now, we created many functions, either with time.sleep within it or not, we created, right? So, and we didn't add this extra option called as daemon equal to true. Now, if I execute the same script, did you understand what happened now? As I created the daemon thread first, the daemon function started, it waited for some time, and it executed. Secondly, non-daemon thread executed, it waited for some time, and it executed. You see here? Means daemon thread generally took more time because it actually is sleeping in the background, right? So it is sleeping for 0.2 seconds. Now I marked it as daemon. Now in this case, see Python space same B7 execute. So the daemon threads and non-daemon threads, which are is happening, it is executing. So sometimes if you want to means like these daemon threads, what is the advantage is that even if they are not executing also, if you want to go ahead, let's say you have a program where you want to install some software and you want to terminate after that. Means like assume that some Windows installation is are happening or like big software installation is happening. You want creating it as a daemon. The program execution will complete and this daemon execution will happen in the background. So even after your work is your main work is done, so till everything is done, we won't stop, right? But if you mark something as a daemon, even if it takes more time also, your main code will execute and complete it. So one more example for you to better show the same example slightly differently I will do. With some change, I will copy the same code again for these daemon threads. So same logging.debug, whatever I wrote here in the top, the same thing I wrote here also. So you see here. So this time I took the things and after that join, when I'm joining, I'm saying like 0.1. Means like it is sleeping for 0.2 and I'm joining for 0.1. Means till that it would be sequential. After that it would be executing. If I say Python D8, you see what happened? After join, still the thread is active. Means now till now you understood that you create a thread, then you start it, finally you join it. So if you don't join, they will execute in a sequential fashion. If you join them, they will execute concurrently. Means which one executes first, which one execute next, we don't know. That's fine. And so you are asking to sleep for 0.2 seconds. Means still it will executing, right? So not only 2.2, you can give 10 seconds also. Means after some time you are checking. So is the thread still active? So the point is somehow you want to make it work for more amount of time compared to this. That's the reason I slept for like 0.2 seconds. So instead of that, if you do 0.2 or 20 seconds or 30 seconds also, means even after joining and waiting for that, still if you see, hey, is the daemon thread still active? If you am asking, it says true. Means generally once join, after the join statement, so anything is coming means it will come only when everything is completed. It will go to the next lines, right? But for a daemon threads, it's not the same. Excuse me. For daemon threads, it's not the case. Even if something was not done also, it will execute it. So that's the beauty of daemon threads. Means if you want something to execute, we can do it. Let me go with some real world examples. Till now we understood the concept. If I go further, you will understand that. So working with these threads, say I have some program to work on some kind of threads, to print some kind of squares or some. I just want to do. So in a conventional way of doing, how I will solve this problem, using threading, how it will be optimizing, I will tell. I have a program called as print squares. It is taking a numbers. For each of the numbers, it is sleeping for 0.2 seconds and printing the squares. Similarly, it is taking some numbers and sleeping for 0.2 seconds and printing the cubes. Now I'm taking an array of values and I initially taking what is the start time, and I want to execute and finally print the total time taken. So start time and like end time I want to do. Start time, and if I subtract with the start time, I will understand the total time taken. So if I execute it, Python, you see what happens? Traditionally, right? It will take some time. So first it is executing all the squares, then after executing all the cubes. Is it clear? Now, with multi-threading, what is the problem that we are solving? How we are solving it? Let's see. With multi-threading, the same problem I will take. This time, using the squares and so and so. Traditionally means what? You have this both. What are the array you have? You pass using the functions. That is how it executes, right? That is what happens. So CLS and Python, C2, if I execute, it is how you traditionally execute. Whereas using threads, also it will execute, but in a much faster time. So how it will execute, I will tell you. So like total time, how it is taking, right? So using traditionally. So say like I will print the statements here. So what are the start time I have? Start. And it is subtracting from the start time. You get the result. Similarly, I execute the same thing again. Similarly, here also using threads also I do the same thing. After computing everything, I ask, hey, what is the start time and end time? So now you see in this case, it will execute. Initially using the ordinary way, using the other side. See, in the ordinary way, it took like 1.6 seconds. But using the concurrency, did you see like it took 0.8 seconds? Sir, it should take much more faster thing. There is another problem called as GIL, called as Global Interpreter Lock. I will tell you, due to that, it is taking this much slow. Sir, you can tell like, 0.6 and 0.8 means it is much more faster, right? but still actually multi-threading should take you much more faster. But in Python, so there is something called as GIL, as global interpreter lock. So every time when you are understanding, you understand this point. In Python can be implemented in three ways. The most flavors of Python are called as C Python. Then other one is like Jython. So other one is like Ironthon. So means like the Python code that we are writing will not go directly onto the machine. So from Python, it will convert to C code, and then from there it will convert to the machine. And similarly, if you go to the Jython, from Python code, it will go first to the Java code, and that will go to the machine. And similarly, for Ironthon, it will go from Python just to the .NET, and like from there it will go to the machine. Means for converting anything to machine, we need to have a compiler. Python don't have a compiler on its own. It depends upon some other compiler. Okay, now we understood there were three flavors. But so in the market, so 85 to 90% of people will work on the C Python only. C Python users only. So now only in C Python there is one problem. C Python is something like a reference based assignment. Means for everything there will be references and it will execute. So due to that, like if let's say there are two threads which are trying to update on the same list. So there are T1 and T2, both are trying to update on the same list. As both are having same opportunity, if both are at a time trying to do on the same thing, then it will lead to some kind of data races. So to avoid this, what will happen if there are data races? Just imagine. So two people came to the reserve hotel room. So the receptionist is there. Assume that both of them are managers, or both of them are like the same importance level people. Then how can a manager decide, like the receptionist decide like whom to give the room? They don't know, right? So they cannot give to one and get the burden of others. So they don't know how to do. If we are human beings, we can take some choice. But just imagine the case of a machine. Machine don't have an emotion, right? It cannot decide on one side or the other side. Then in that case, it will not do anything and it will stay calm. That is called as a deadlock. So due to the this is called as data race. So both are trying to update the data on the same thing. So both are in a race to update it. Due to the data race, we will get the deadlock. Deadlock means nothing will execute. When nothing will execute means nothing will happen. So there is a lot of work, nothing will happen. Means all the resources are weighted, right? To avoid this kind of case, so Python, what it does, interpreter, it is something called as global interpreter lock. Means it will take one thread, safely lock it, and execute and release. So like that, it will do the same thing again and again. So due to that, what happens? So though, sometimes it may perceive that, all are executing concurrently, but in the backend, it's not happening so. So to the best of it, max, it tries to switch between these things. But even then, you see, you get some kind of advantage, right? So it's still fine. But in which task multi-threading is more suitable? So multi-threading, as it has this kind of on and hop kind of things, it is more suitable for like IO bound activities. IO bound activities means what? So means like any kind of inputs, outputs, and all this. For other things, we have like multi-processing for like CPU bound activities. Now the same problem which I solved right now can be solved much more fastly if I go for multi-processing, sorry. But even then, multi-threading is not a bad hawk. We can do certain things, but not as expected in compared to other languages in multi-threading. But did you understand the background of why we need these things, how it is solving these problems and others? Is it clear? It's clear?
Yes.
Fine.
Yes.
Now, again, solving the same problem, you solve like this, right? So let me tell you one more interesting thing. So the same problem I will solve so in a better way. This time I use a new thing which you have never used till now. As underscore underscore name underscore underscore. The first time. What is this I am using? What is the purpose of it? So the purpose of it you will learn shortly afterwards. Um, as of now, you think, right? If you want any code to be executed directly, you use it. Means a Python script can be executed two ways. Either directly you can execute, right? Any Python program, Python space C3 if I say, it will execute. And in this code, I wrote two threads and I started them and I asked it to join, and then like I am done. It will execute. Alternatively, also you can do the same thing. Means say like I am going to the Python, like IPython or whatever might be, interactive mode. I am going in this directory. In interactive mode, what will happen? You take the same thing. So if I go for like import os.list.dir means what? By default, if you don't give any directory, it will try to give in the current directory, right? In current directory, don't you think this file is there, C3 thing? And a Python script, not only directly, we can also import like a module. Do you know that a Python script can also be imported like a module? We should not give .py. We should just remove the .py and just give the file name. So did you see what happened? So when you executed like this code was not executing. Means why I wrote this underscore underscore name is equal to main means this underscore underscore name will be equal to main only when you execute it directly. When you do indirectly executed, it will not happen. So that is the reason I did it. So if you want to see like what is this value of underscore underscore name underscore underscore, right? Say underscore underscore name underscore underscore. So if I just come out of it, okay. If I again go for IPython, so first of all I do directly Python C3. If I execute, did you see the name is equal to main? Similarly, if I go for IPython, and similarly if I say import, I am in the current directory, right? It has these things. If I just execute, did you see the name is not main? Means any Python program can be executed either directly or indirectly. So indirectly means like this importing in another module or IPython or some other way. So there is a process. I will tell you how to create our own module afterwards. But you understood now, right? This is the best practice when you go to the production codes. Every time we need to write like this, such that accidentally this code will not execute whenever someone want to reuse also. Hope it's clear. So this is how like a production ready code. Then, so if you want to execute one more program, say like that, you can do like a safe execution. Say like if you want two arguments and you want to pass, you see, I have a function. If you pass two arguments, it will execute. I created a thread and executing. Instead of doing directly, I created like a main function and executing. Means people who came from Java background, they do these kind of things very common, because there the main function or main thing is needed for everyone. In Python, there is nothing like main. Whatever you execute, it will execute. So those people who came from that environment, they mostly use this kind of notion. Means whenever they came from one language, they want to implement that language features everywhere, right? So that kind of people will come and do. So there is nothing wrong, but that is the way they have done in the other languages. They are coming. And similarly, in a thread, for your ordinary function, you can ask like thread.name and the arguments and keyword arguments you want to ask. What are your passed? Till now, you have a function. If let's say you have one argument, two arguments you passed, right? But you have like any number of arguments you want to pass. It's up to you. For the thread also, you can create a name. And after that, you pass the function and you do a start. You see, in this case, I am doing a creating and starting both at one shot. Earlier, what? We created a thread, we assigned to a variable, and to that variable, we did a dot start and dot join, right? Join is not mandatory, but start is mandatory. So if you do join, it will do sequentially, so non-sequentially. So if you do join, it will ensure concurrently. But you see here, I created a thread and started. This time also I created a thread. I gave some name, I gave the function, and apart from that, I gave arguments. Third time also I gave the name, so target, and keyword argument this time. So 3 ways I executed. Now, if you execute this, you will notice that, okay? So whenever I am executing, I can do. Means in real world, when you're executing, you can create functions like this, which can accept any number of arguments, and also you can work on them. Hope it's clear. Like this kind of custom threads you can have. Hope it's clear. So not only this, we can also go with the different kinds of other threads also. Maybe like once you go to the classes, you will understand like how to create a class and others. So in Python, if you want to create a class, this is the syntax, and you write what are the class name, whatever you want, and you write what are the methods you want. Like a ordinary functions, what you write till now, right? Like that, you need to write a methods. That's it. So class will have methods, where ordinary functions are if you combine like this. Similarly, if you want to create your own thread class, so you can inherit this one, and you can pass on. Maybe this function, this script you can reserve when till you understand the classes, and you can come back. So till now you're creating a threading class, threading functions, right? But if you want to create a thread class, so you need to do 2 things: this constructor and a run method we need to implement. That's it. So till now what you are doing, you are using the existing thread method, right? Threading.thread. You are using this threading.thread and you are passing the arguments. Similarly, if you want to create your own custom thread class, so whatever is there, you want to customize. So in Python, anything we can customize. If you have an integer and if you want to create a custom integer, so this is like custom int. If I want to create, you pass like int function into it, and you do whatever you want inside. It becomes a custom int. So like that, anything you can create customization in Python. So whichever you want to customize, you pass as an argument. This is called as inheritance, and you do use it. This method expects only 2 things: the constructor and the run. There should be a method named run. That's it. See, like ordinary thread, how you are executing, I am passing to this thread. This thread is taking like this, and it is executing. So just to, as I am giving all these things in one shot, I'm just showing you here itself, so that you will better remember. And in the same fashion, there is one more thing. Say like this function based, there are like other kinds of things like class based. I just told right now, right? Class based things. But further to understand, you need to understand how to work with classes. But like the next thing that I want to focus is on the most important thing, which is the locks. What do you mean by locks? Okay, this is the most important thing. Whenever you are working on threads, so this is most important. There are like, say, now you're working on variables. What if you want to work on a file or something which is there commonly for multiple things? If let's say, I told a previous example called as data races, right? How do you avoid that? So just because there were data races, we have multiprocessing, I told. But how to handle it better way? 2 resources are concurrently trying to update on the same thing. Then how to do? That is where locks comes. Lock means what? Simple. If let's say 2 people are there, so they both want to update into the same box, then what will you do? So the box you give to the first person and you lock it to him. So he will open it, he will add something, and he will close. And again, he will do the lock, and he will do the unlock. So it means acquire. Unlock means acquire, and release. So there are lock will have 2 states, either like acquire and other one is release. So if you want to use it, first you need to acquire, and after your use is done, you do release. Till you release it, others people cannot access it. So with that, we can solve this problem. Now let's see the data race problem, how it is occurring. and how we are addressing it. So race condition. So how this race condition comes, how we are addressing it. Let me tell you a simple example. You see in this example, what I want to tell. So it is one function. Before even going there, so see simple function. So we are creating two threads. This function is taking two arguments. You're passing and you're creating the threads. You are starting, you are joining. So don't you think it's like an ordinary thread only? Fine. Within that, what logic it is doing, I will tell you. So I have a integer variable, means like a int means like immutables. What are changes you do within function will not reflect outside. If you want to reflect, you need to mark as global, right? So that's why mark it as counter equal to 0 outside, a global variable, and a marking is global. Within this, if I say anytime counter, so the value will increment. So if I give some value, it will increment that value by that. Means it will take the existing counter and it increment the value. And it will sleep for that 1 second. And again, it will print the counter. This is the simple job it has. Now we see here in this example. Logs. Python. You see now in this case, what will happen? Two threads were created. First, the 10 argument will go. It will give the value. Initially, it is 0. The counter will become 10. Then the second one will go. The counter will increment by 10, which is 20. Okay. You are story updating on the same immutable object. You are getting it. Fine. Okay. So you have this thing. So both are trying to execute. But can you tell like which one executes first and which one execute next? Can you give that kind of clarity? Or at least can you reserve to one without when other one is not accessing? So these are immutable objects. But if you go for mutable objects, things will be much more problematic. And of course, it won't even work. So that's why I showed with immutable objects. For you to understand. Now here, what is shared here? This counter as a variable is being shared by both the threads, right? Within the function, they are trying to update on the same variable. It is kind of shared. So then in this particular sharing scenario, how to address this race condition? The solution for it is very simple. Whenever you have something, before even and after modifying, there are two things we are adding. So get control, so release control. You see here, after your work is done, you are doing a release control. Did you all understand what I'm trying to say? So if you are doing any changes, before and after doing any change, you do this thing. For that, first you need to create a lock variable. Lock is like again a global variable you need to create, and that you need to pass. Earlier you just passed a variable, right? You need to pass the lock object also. If you pass this thing, now it will execute. You see now, the race condition was executed in such a way that one will not affect the other. In earlier case, what will happen? The first one is 10, second one also got 10. That's the reason final counter is 20 only. It should increment, right? It should become 30. But did you see in this case, as both are not hitting, don't you see that the problem was addressed? So by design, the logic is in such a way that the existing value should be incremented by whatever you give. Initially, it was 0. You gave 10 means it becomes 10. So, and after that, you gave 20 means existing value is 10 because it already updated. It should become 30, but it's still 20 in the previous case. Now it got 30, right? Now, did you all understand what I'm trying to say? So,
Yeah.
yes, so each one can individually access. So if you don't do like this, what will happen? When you are creating two threads and you are starting, both will start at one shot. So you want when someone is using, other should not touch it, right? Means it should wait. To make that, you are doing like this, acquire and release. So let me give you one more example. The same thing we can solve with a class based also. I think slowly you will learn about these classes also, this process. So as I'm working on modules, I'm telling here itself. So simple. So even when you're working with threads also, the same thing happens. So I have this counter. So here I want to do something. So I created a counter and I want to work on this method. Only this method I want to update. So same like a function. So you will understand slowly afterwards how it is a class and others. It's not a big deal. Here also, did you see that I'm doing a getting control and releasing control? No, you are doing releasing control. So you are taking the lock. Some way or the other, you are taking the lock dot acquire dot release. So like that you are doing. So this is one way of doing in a better way. So now, not only this, one more example let me take. Here also the same thing happens. So to say again, why we need the concurrent things? Whenever you are doing multiple things at one shot, to better handle it, we need it. Say one more example, if I say here, you see in this case, I have a transaction. I told whenever you want to use lock to the function or to the class also, method also, you need to pass the lock also. So you need to do the lock.acquire, do whatever changes or print or do anything, and you release finally after your work is done. You see what are the things are there I do. So for that, first I need to create a lock, which I told you. First we need to create a lock. That lock we need to pass to everyone. If let's say now I'm creating two threads and I'm joining and I'm passing. You see now what will happen? I created two threads. I gave a target is equal to this function. Arguments are two things. One end the thread, similarly two end that lock. If I pass, now the same thing happens. If I see clear, I think previous example itself you understood very clearly. So syncing with threads. So initially when the first thread was executed, you see from thread 1 came. So next from thread 2 came. So end of the code. If I don't do, what happens? By the time it is getting printed, maybe second thread will execute and you will get something else to print. To avoid those kind of things only, this threads.lock will really help you. So there were like different examples I can take to help you understand a much better way. But this is the main purpose of any threads. So let me give one last example with this thread.lock before going to the conditions and going further.
Yeah,
So
Uday, sorry,
please,
I have one question. So
please.
basically, create the lock.acquire is working for the trade for the first time thread, like T1 we
Yes.
created first thread, so it will
Mhm.
execute first thread. It will lock that thread, and T2
Yes.
thread it will lock. It will not execute, right?
Yes. So if something is locked, the other thread will wait.
So basically, whatever the first thread we are giving, it is execute first, right?
Yes.
That
Yes.
okay.
Yes. So that's why you see earlier when threads were not there, locks were not there, all will execute in one shot fastly. Whereas here, you see there is some pause, right?
Yes,
Okay,
yes,
we can understand.
yes.
So when you go for real world problems, you cannot see that clearly. As it is a small example, I can better illustrate. But when you go for real time, things will be very complicated for you to analyze. That's why I'm showing example. You see now. So till now, what I showed, I passed a function, a lock I created outside, and I passed to the function whichever I'm calling. Along with the arguments, I passed the lock also. But this time I'm taking this thread lock at the global argument and I'm using inside. So dot acquire and dot release. This is also another pattern in which you can use. So it is also same thing. So this is another problem we solved. But like here also a similar pattern works. But here in this example, I am not passing as an argument this lock, but it is like a global variable, this thread lock. So this is also another way. And the next thing, there after doing all these things, there is one more thing about the conditions. So in threads, when you are working, there is one more thing called as conditions. What are these conditions? How they can help us? If I can see fastly. So till now we have like creating a threads. So we can have some kind of locks, and we never seen about a conditions. So what are these conditions? How they can help? If I can notice, generally when you're working on it also, we need to have inter communication called as ITC. So till now we have seen threads executing, but we never connected from one thread to another, right? Just every thread we executed, that's it. So if you want to do that inter-thread communication, that's where this comes. So this is a process where like communicating between the threads means if you want to share data between two threads. So that is where like it comes. Whenever the condition objects has five states basically, whenever you want to communicate the threads. First one is acquire. So till now, you know, acquire and release. These are the two things you know. Similarly, there is another called as notify, notify all, and wait. So you know only these things till now. Acquire means whatever you are seeing right now. Initially, if you want to access any shared resources, if you want to share, and before even that, first if you do acquire, other threads cannot take it. And you can do whatever actions you want till it was locked to you. Then if you want to notify, in this way you can notify to a specific thread, other target thread, that hey, you want to take or something. Or if you want to notify to everyone, that is also do. And if you want to make to wait, after, you know, it is used to make a thread to wait until the notification is done, or like wait until something, or wait for some time. And finally the release method. So till now you know the first and last methods. Now you will understand the remaining three. So notify, notify all, and these things. So to understand this one, so we need to go for the notify things. Maybe we can start that in the next class. We can stop here.